around the area of application security, especially in the area of the code and using the code to try and drive some of that. I just want to get a feel for the audience here. Could I just give me a quick show of hands? Hands up here who would be from the testing or penetration testing backgrounds. Okay, not too many. How many would have more of a development or coding background? Oh, right, great. And how many would be, say, management or risk management backgrounds? And for the ones who haven't put your hands up, what the hell do you do? I'm kidding. So, we're going to talk about this research we've done. I'm going to give a couple of provisos first. I'm going to talk a wee bit, and then Jan's going to do the technical bit, and then I'm going to come back on and talk about some of the future research. This was driven by something that Uleska started with CSIT. Now, Uleska's a company I run. We do services, pen testing, training and stuff like that there, but we also run a product. This is not going to be a product presentation. We've very carefully made sure there's nothing in here about the product. It's all about the technology in the background. So some things there we might do, some things we won't do. We're not going to tell you about it. We just want to talk about the actual technology. So let me just start the timer here. So myself, I'm founder and director of a company called Uleska. I'm also involved in OWASP as a board member and stuff. I also used to be a security architect at Citigroup, and that's actually where some of this impetus or ideas came from, because we saw when you're working in a large bank like that, the scale of cybersecurity, you could triple, quadruple the number of security people in that company, and still you're going to have a hard time scaling out to the whole software organization. Jan's from CSIT. He's going to introduce himself when he gets to his bit. So software development has accelerated and improved in every other area apart from cybersecurity. As a developer, you really feel that. We've got continuous integrations, your Jenkins, your DevOps, we have Agile, we have all these ways to developing software a lot faster than we did whenever I started. When I started, you had a C++ main function, and away you go. Hands up here who started with a main function. Okay, that's a small number, so it's now you stick in Apache, you stick in something else, and you build on top of that. You can have 4 or 5 lines of code running a whole application. So it definitely accelerated everything, but cybersecurity, trying to secure all that, still takes weeks and months. Sonotypes say that the average time for a high-risk issue to be fixed from the time of the security test is 6 months. So it's got a long delay there of security issues being in the software. And let's start with the fact, application security industry already knows how to fix every issue. Cross-site scripting, SQL injection, we already know how to do those things. Yet we still see a lot of those issues. Interestingly, as a parent, and this is kind of a slight aside, but you kind of get really pissed off whenever you see these things happening, whenever we already know how to fix it. Anytime you see those issues coming along the news and you know, oh, we know how to fix that, that's 20 years ago. Now, as a parent, my kids are 10 around there now. I'm thinking in 10 years' time, they're going to be driving cars run by this stuff. They're going to be putting their details into bank accounts, whatever, probably built by the lowest bidder, by a coder who's the cheapest one they could find. So we want to try and make sure we're able to secure these things easier. And with me, the issue is actually execution. It's not unknowns. We know how to do SQL injection. The issue is making sure it's covered everywhere it needs to be. So where we want to go is, we already know there's not enough people to do it. We already know the skills do or do not exist in the industry. We want an output here on the right-hand side that is secure software. That is our aim, that's our goal, and that's what we do right now with the security testing we do, or the scanning, whatever. Now, if we want to automate this and not take it into such a manual task, we have to see what inputs can we use to produce that secure output. Now, interestingly, I knew of a colleague in the past who, on the left-hand side here, we've got documentation, and the bottom picture is just code as inputs we could use to try and understand what security we need to apply. Because any pen tester knows the security information, but they have to know how to apply that to the particular application that's being tested. Now, a colleague of mine had done a lot of work, this is a number of years ago, on trying to understand security documentation. He wanted to try and analyze that and see if he could work out automatically the attack surface of the application from the documentation. Now, to me, that's insane. A, it doesn't bloody exist half the time. B, it doesn't bloody exist most of the time. And C, it's usually not very specific. I know even now whenever we do pen testing for customers, and you get the security, the documentation of what the application is, it's a quick diagram, and you don't have much else to work from. So using the documentation is very hard. Plus, the documentation is written in English language. which is hard to parse and hard to understand for programs. A much better place to start is the code, because the code is the truth. The code is saying, I have a web servlet here, I store this in a database, and we can use that, with, especially with things like code-driven environments, etc., to really understand what is in the application based on the code, and that's what the focus was of our research here. So as they say in the adverts, this is the sciencey bit. I'm going to pass it over to the expert, Jan, who's going to explain how they got involved, what they did, and how they built a scanner to understand from the code what the overall attack surface of the application is automatically. So I'll introduce you to Jan. There you go.
Yeah, hi. My name is Huang. I'm a senior engineer from the CSIT, that is Center for Secure Information Technologies, which belongs to the Queen's University, Belfast. And CSIT is the UK's National Innovation and Knowledge Center for Cybersecurity. And recently, CSIT launched a program called CSIT Lab, which is the incubator program which is designed to support new cybersecurity ventures to start, scale, and engineer MVP, minimum viable product. So the successful candidates of the CSIT Lab will be provide 3 months fully funded engineer support for the production, prototype, or proof of concept technologies. So you can go to the CSIT Lab website to find more information, because next round CSIT Lab application will start in next month. And Alaska is one of successful applicants of the CSIT Lab. So so the first time when Gary asked me to develop a source code scanner that is able to find out web page information from the Java source code servlet, as well as the post and get parameters, the first pop up in my mind is to use regular expression to search certain patterns. Okay, so I did some research. So then I found out, of course, regular expression can pass in regular language, and according to the Chomsky hierarchy, there are 4 types of the grammar for programming language, and from top to bottom is type 0 to type 3, and regular language is the type 3 grammar, and however, the Java programming language is a type 0 language, so which is incursively enumerable language. So it's impossible to pass the like infinity native structure of the Java language by using regular expression. So that's why I need to find out another approach. So this is I look at another language parser, and this Java parser is the first parser I use for this Alaska project. Java parser is an open source library which allow you to interact with the Java source code as the Java object representation in a Java environment. So here we refer to Java object representation as the abstract syntax tree. So as you can see, now I give you a very simple examples. And here we have just a Java class. So a few lines. This Java class just print out the current time. So you use the Java parser, you can pass this source code to a syntax tree. As you can see, the root of this tree is called the compilation unit. Okay, and this node represent the whole source code. Then it got 3 children nodes, one for the package declaration, one for the import, and one for the class declaration. Okay, this is what you thought is not the whole trees. Consider the this triangle notation. You see, this indicates this portion has been summarized. Actually, it can further branch out. So let's take example. I just choose one node, method declaration. I just make it further elaborated. So you can find out what's the return type of this method, what's the name of this method, as well as the parameters and the block statement. Again, the last two nodes can be further elaborated. So after you use the parser to parse the source code, then what you can do is this Java parser implements a visitor pattern. Okay, so you don't need to traverse the whole trees. You only focus on what you are interested in, then define the visitor, then open on the node you are interested in. So after that, you can analyze this tree and try to modify the node. You can also generate a new source code through this modified tree. Actually, I love this Java parser. It's easy to use and it's well documented. But later on, Gary asked me to do very similar things for the C# source code, because that Java parser is only for the Java language. So then this is the antler comes out. This antler stands for another 2 for the language recognition. It's also a open source library. So this antler can not only pass the C# code. Actually, it can pass any language as long as you have the grammar of that language. So when you use this antler, compared to the Java parser, there are a little bit more you need to do. So first of all, you need pass the C# grammar to the antler. Antler will generate the C# parser. Okay, so this is just one-time execution. You don't need to do every time. So after you get this C# parser, so then the next step are very similar to use the to the Java parser. Okay, and actually antler have 2 working mechanisms. One is same as the Java parser, use the visitor. Another one is called listener. So now I'm going to show you a very simple examples how to use this listener. So as you can see, we have a very simple statement, assign statement. Okay, that which is assign value 100 to the variable sp. Okay, so you can see the top is the syntax tree for this assign statement. So how this listener works? So antler first will generate a bunch of API. So when this tree work traverse the tree, so for example when this tree work uncount the node assign, so first the method called enter assign will be invoked, and also will pass it to the assign context object will pass to it. Okay, after that this tree worker will traverse all the children nodes of this assign node. So after that where the exit assign method will be invoked. So what you need to do is because the antler already provide you the API, so you only need to override the certain method you are interested in. So as you can see in the right top of the figures, you can it shows the complete sequence calls made to this listener for this assign statement. Okay, and this is all about language parser. So now let's back to the Alaska project. So after I use this parser to pass the source code, for example, the Java source code or C# source code, then I will store all the output in a JSON file. Then the Alaska will use it, for the further development. Okay, so yeah, that's me.
Okay.
So, yeah, I just give back to the Gary.
So thanks, Jan. Thanks very much. And just to mention, yes, CSIT Labs is actually a great program. Within 3 months, they were able to analyze the different ways of doing this for us, build a program that did it, and also test this for us. So now we have a facility that can just sit in the source code of the directory, a tool at the command line. I run it, it does lots of fancy stuff, comes back to me with a JSON output, which is all the web interfaces of that code line. What parameters they take in and get and post, and other things like that. And that's just as far as we've been. You could extend that out anywhere else. Imagine you could look at what files are opened, what databases connections, all that other sort of stuff. So there's lots of interesting stuff they've been able to do here, which has been great. And as we said before, we're trying to automate here. We're trying to actually take a lot of the tasks off a human and make it easier. So with the assumption then we take this forward and we have a complete project model, we can actually scan a code line and understand the interfaces and all the things we want to based on the commands it's do. What can we then do to try and get towards this area, as the title of the talk is, of self-securing code? What can we do there? Essentially what we're going to do is take this project model and understand that as a representation. Anybody here who's a pen tester, you'll understand that that's just what you read from the documentation. This is what you try to understand your first days or weeks of working on a new sort of pen test. Because first of all, you have to understand what the darn thing does. Does it take in credit card numbers, or does it take in baking recipes? How much do we care about the different things? So imagine we're able to get this project model digitized and holding it ourselves. And just one other note there, everything Jan worked on was open source. There's no IP there. All of that can be replicated by anybody else in this room. In fact, one of the reasons for Jan talking here was also to let you know what worked for him and what didn't. So if you're going to do the same thing yourselves, you can do it a bit faster based off what Jan was researching. So we have a project model, and that tells us, is it a web application, is it desktop, what does it do? You could then take a security model, which if anybody here works in a bank or even anything doing 27001, you could get a security model. What security do we need to apply? Is there encryption needed on certain types of data? What data levels are there? Is there sensitive? Is there public? Is there informational? You could also then say, well, if something's going in transit, something's sent over a network interface, does that have to be encrypted? Does it have to be protected with certain headers? So imagine the technicality of the security model, probably what would sit in your secure coding guidelines or your security standards. And if you digitize that and then combine the two with some sort of engine, you then have the ability to actually automate a lot of the security actions that need to be done. You won't do everything, but will we get 20%, 50%, 80% of it done? Can we cover off a lot of the standard SQL injections and cross-site scripting injections that then allows the pen tester to do more interesting stuff in the 4 weeks they have allocated? Or can we give something to the people who can't afford penetration testing to provide a level of security for themselves? Because remember, I worked for Citigroup, obviously one of the biggest banks in the world, and I saw the security organization they had. Very interested in them moving to form their own startup and being amongst that startup community, who are struggling to even get a developer to write something in 4 lines that is a website for them. I come along and say, oh, well, this is secure. And I won't say what they say back to me, but it's not polite, because they don't care. They're just concentrating to get some functionality out. They can't afford a 20K pen test until they're successful, until they actually get to the point where they're going to sell to RBS or sell to Citigroup or whatever. And then the banks come back and say, well, here's the big spreadsheet we assume of the security you have in your system. And they go, oh, dear, I don't have any of that. And then they have to run around and get a pen test and put the security back in. But the problem with that is you're wasting weeks and months to go back and recode what you've already done to make it secure. It'd be nicer to actually have that heads up. There's a company called Denim Group, based over in San Diego, who are doing the same sort of thing as us. But they have a very interesting thing where they check every check-in in Git and run something like this here to say, oh, is that a new interface? Have they put in a new servlet? Oh, let's be very aware of that right now and do security stuff with that. So instantly, you're knowing what security is being applied by the developers. So that's a very interesting way of going forward. But what could we do with this here going forward in a perfect world? Very simply, we could create our own documentation. Java Docs does this to an extent. But Java Docs is usually reliant on you having to actually fill it out. It gets out of date whenever bug fixes go in, and it doesn't cover absolutely everything. Here we could actually use the engine to even simply enumerate what the web interfaces are. You could even start adding in information about the roles that use those web interfaces. You could have extra stuff, extra annotations to declare the sensitivity of the data. This CC underscore card header or post parameters coming in, is that sensitive information? If it is sensitive information, what does that mean to us? Well, then we go to security document, the security policy. Do you understand that? So we can simply do documentation. You can describe data flows. There's already some programs out there that do things like that there, but we can understand that from a security point of view. Sensitive data comes in from the website. Is that external? Is it internal? Is that stored in a database? Is it sent off to another application? If it is, can we model the other application and have a chain actually through our organization where we know the data flow and the sensitivities? And if we have a chain of 4 applications, and this development team thought CC underscore number was actually public data, we can recognize, oh, hold on, that's going to be an issue because we're not protecting that in the 3rd application. So there's other things you can do just by modeling the actual code and using the code as the truth to understand what the application does and speed that up. Slightly more difficult things we can do is combine it with a security module and actually generate code. If I said to you, mostly developers here, if I said to you we have a security policy that says credit card numbers are financial information, and our security standard says financial information has to be encrypted with AES 256. Well, as developers, any of us will look at a piece of code, see the credit card number coming in, and know pretty quickly if it's being encrypted or not, or if it's just being directly stored in the database. Now, if we can identify that quite quickly, can the code generation engine actually then generate a library, OpenSSL, or reuse Spring Security or something else to actually then say, well, here's a .jar or here's a .so that we can plug in to do that. Now, you get advantages of scale there, because if you're saying every credit card number, every financial data has to be encrypted with AES 256, you can plug that out throughout your whole organization, your whole code base. And then later on, if you say, well, hold on, it has to be AES 512 now, you've got one place where you change that, and all the financial data is now being encrypted with the right information. Simplistic, but it's a way of moving forward and making it a lot easier. I do know from previous experience, and I won't say which particular companies, but security decisions have not gone through, security changes have not gone through because they just realized it was going to cost too much to manually go in, change the code, analyze what systems need to have the code changed. They just said, oh no, it's too much. We're not changing from 8 character passwords to 10 character passwords because we've done the analysis and it costs too much. So security is being hurt by the cost of how we do it. If we manage to automate a lot of this, bring down the cost, we can do security changes a lot easier and a lot more efficiently. Security configuration. There's a company over in America has a patent on this particular bit which says, I'm going to understand where my network is, and I'm going to automatically create the roles and the firewalls or the IDSs or the network components and change the configurations to say, I know I need to protect that because I know there's sensitive information coming in here. And by the way, oh gosh, there's trades and acquisitions data going into that wee box there, so that makes sure the network around there is not available to the whole of our massive organization, that we can tie that down. A lot easier to do it there if you have a model in front of you of how the architecture is actually looking. Security test generation. Can we plug in with things like SQL map, with things like burp? Can we actually even create our own Python or C++, whatever libraries that allows us to test? Because we know from the project model, there is a interface called /add credit card. Now, if we know they're going to install that on Jenkins that night on this box here with the DNS address, we could automatically create a function or a tool that sends the requests in and says, well, I'm going to test that if I put in a credit card, great. If I put in an invalid credit card, fine. And how does the encryption work? That's like a lot of companies are moving towards that sort of automation, but they're manually creating the automation, which is very slow and very costly. If we can automate the creation of the security tests, security becomes a lot easier again. There's also a skill to that as well. I do remember working in a previous company where we had a lot of automation tests and we were getting about 60% of them were passing. And then something went wrong and it went down to 20%. And we thought, who's broke the build? What's happened? It turned out something went wrong with the installation of the build. So the question doesn't become how do we go from 60 down to 20? How did 20% of the tests pass whenever the darn application wasn't even installed in the test box? So writing tests is actually an awkward enough system to do. So automating that there and doing it once and repeating again is a lot easier way to do that. And then to the crux of what we're saying, and this is it pie in the sky? Is it something we could try and achieve at a smaller level? But you have even things like IDEs, not Jenkins, sorry, Eclipse. You know, if you want to have getters and setters, it can automatically create the code for you. It automatically create the servlet code for you, that sort of stuff. So we've already got things that can create a bit of code for us. Now back to what I was saying before, if we know a credit card number is coming in off a web servlet, and we know a certain level of security has to be applied, and we know we can create a library which can apply that security and give them an API to do that, can we automatically apply the code, that code hook? Could we automatically create the library during the build, put it into the jars that are needed for that, or the SOs or whatever, and actually write in, just after we read in the credit card number, the encrypt or protect credit card function, and therefore automatically have this done a lot smoother and a lot more automated? How much of that would work? Is a credit card number a very simple example? Does that get stretched out whenever you try to do other harder things like headers? Or if you're actually talking about stuff being stored in a database, how do we check that's maybe encrypted in the right way or whatever? But that's something we're going to try and research and see if and how much of the security coding wise we can actually automate just from somebody putting in the code. So we're even thinking about putting in the IDE. We could put a plugin into Eclipse that recognizes you're taking in something. As soon as you say this post parameter is sensitive, it automatically writes in the code to protect it. You know, is that possible? We haven't tried that. One of the reasons why we haven't tried that, and it's actually great to have an audience here full of coders, is because in my experience, and this is only anecdotal, a lot of people who are in the security world or the testing world, or pen testing world, aren't developers. That person I mentioned before, he was trying to use the documentation to try and read that there. It's because he'd read something that knew how to parse documentation. He never considered doing the code because he wasn't a coder. But we're all coders, we all know the syntax and the controls they have. And here what we're doing is slightly different from some of the other code scanners. The code scanners come directly from the code, use the syntax and semantics to say, you got an SQL injection or something like that. Doesn't care, they don't know if it's sensitive information or not. They don't know what encryption is supposed to be applied. They're just using syntax and semantics to say SQL injection or this exception gets printed to a log. And that's why they have so many false positives, or even, it's not so much the false positives, it's actually raising the issues that don't care. That's another thing I have a problem with those sort of scanners. Here we're doing something different. We're not going directly from the code to an issue. We're going from the code to a project model. We can understand the project. We're simply saying it's a web service that takes in the credit card number. And then we use the security engine and the security model to try and combine those two things and actually make some interesting outputs. So that is something we are playing with, something we're going to look at down the line. And one of the good things about showing this to people like yourselves is if you have any input, if you've any experience doing this here, if you've seen something else that does the same, or if you've tried this here, or if you see something absolutely, oh, it won't work, or it would definitely work for that, please give us your feedback, let us know what you think, and so we can try and make sure we're putting that into our development going forward. Okay, thank you very much. Thank you. Does anybody have any questions for myself or Jan? Yes.
Just ask, you're using an example of a credit card, and identifying credit cards that based on actual variable type, or based on naming, or I'm just trying to get an idea
Yep.
of what you're parsing.
So yeah, right now, all you have in the code is a name of a variable, and you haven't a clue what that is. Now, if they do it CC_number, that's quite easy. They could call it ABC, and you haven't a clue what the hell that is. So the question is, there's a couple of different ways you could do that. One is have an annotation above it saying, this is financial data. I now know that. Or you could actually, it's a bit hard, I don't think it's really take off, but you could actually have a naming convention, you know, _fin at the end of everything. I don't think that would work as well. I think the annotation would be better because it would be more flexible. But you would have to elaborate some of your code for that. But like I said, we've talked to people like Pivotal and other large companies that got there, and they're moving towards that infrastructure as code anyway, so they're looking to keep everything in there. So they'd actually love to keep all that security information in the code, because then if the whole team disappears, everybody else coming in says, oh, I now know what this does because I know this is financial data. One of the biggest problems I've had in my time of either being a security architect or a pen tester is talking to people in the team who just don't know the software. They're in the team 4 months and they didn't work on that bit, and they didn't realize there was an API over here that had a web service that allows you to put in the SQL you want to be executing in the database. And that's one of the things we have a problem with. Yes?
Back in it,
Yes.
In essence, you're going to anyone buying software that you're generating, it's going to have a developer education, or a lot of the time the standard is not there for it to be consistent.
Absolutely, and that is a challenge, absolutely. In large organizations and in small ones, they just don't do this right now because they're having to worry. But if you get to a point where you're saying, well, you don't have, and they don't have the annotations or anything they got right now, but here is the security task you have in front of you, and at the end of the day, you're going to have a pen test document or something they got there after 3 months or whatever. If they then say, well, hold on, if I then put the annotations in, that speeds everything up, I can get the documentation quicker, and I can then get the pen test or whatever quicker, that's a selling point, and that's something you're going to have to show the value. But you're very right, it's not there right now, and it's something that's going to have to be encouraged to change, and you're going to have to show people that by putting that annotation in there, it saves you 3 weeks of work later on. And it actually then becomes it could become part of the coding standard, but you're very right, that's something that needs to be challenged and encouraged and probably driven by management in terms of the security angle. You're very right. Yes, please.
Have you tried this on any real projects? I'm not sure how far you are in progress.
Oh, so that's my timer. So yes, we have trial websites. We have set this up to do this here, and also we got coded some open source websites just to make sure it worked. And without going into too much detail, the product that's built off some of this here is already in trials across the UK, and so we're just running against that there. Absolutely, a lot of times it works fine. Sometimes it fails miserably. That's part of the development. A company we came across actually used the JavaX web service, the JAX web service annotation. We don't cover that right now, but we know how to do it. Just a development exercise to get to that point. And that was again part of the research that Jan and CSIT Labs were able to do to let you know how to get to that point where you can extend it. Any other questions?
Is this mainly about automatically creating tests security, or is it also about automatically creating secure code?
What we're talking about here is mainly the scanner to be able to give you that project model, and that's in the last few slides I said, you can do whatever you want. So my product does some things around there, doesn't do all of that there. Some of the risk people I've talked to, so people who are maybe contractors in terms of risk, sort of GRC, risk compliance, they see angles saying, well, if I understand even at a project level if they're taking in financial information, even that level, if you use that across, say you're an enterprise and you've got 10,000 projects, 10,000 applications, you could have everybody run a scanner like this here, and then immediately you know, all right, we know what services we have high-class financial information. So they see that sort of angle as well. So I'm really talking about the sort of scanner here. Also, even if you think about it at a very high level, you could say, check what libraries we have. Are we using a certain library we now know it's out of date? Are we using, I know Heartbleed is used so many times and I hate even mentioning it, but you could say, oh, well, are we using the version that has Heartbleed, and are we using that against a baking website or a financial services website, and then you know your risk. So they love to know the stats of their risk and love to have a pie chart saying what is the risk of the overall organization. This could help do that. Again, I've worked in large companies where the SH1T has hit the fan in one way or another, like an Apache Struts problem. You take weeks to understand even what applications you have using that version of Apache Struts. Never mind going to remediate that. So again, this sort of scanner could make that automated.